In this video we're going to look at how we analyse the information you collected at Nappa scar. So the analysis involves four things. You have to describe all the geology at each of the sites and then interpret all that information, i.e. say what it means. Once you've done all the sites, you put all that information together to form a synthesis. Now, analysis means cutting bits up into smaller sections, i.e. all the sites, and synthesis means putting all that information back together again. Once you've put all the information back together again, you then make a conclusion and say whether your hypothesis was proved correct or incorrect. Now, don't forget to use the website to get all the information, all the photos you can see down here. You can click on this link and all the photos will come up. There's a brief outline here of what analysis involves. I'm just going to go through that in a bit more detail. So firstly, it's always worth doing an overview page. You can see here I've put the overview photograph in to show where site 1 is, where site 2 is and where site 3 is. It gives you a good overview. Anyone reading your report will be able to see where all the sites were. We walked up here, the footpath was up here, and I've drawn at the bottom here a little field sketch just to show the location of the footpath where we think, or the hypothesis is, there's a possible fault line. Site 1 above the footpath, site 2 here, and then lower down site 3. So that gives a good overview of where everything is. We should ideally have an orientation line, and I should have a scale in here as well. Once I've done my overview, I can do site 1. And site 1 needs a detailed geological description, so using a photograph like I've done here, and then I've drawn, you can either annotate the photograph or draw a version of your photograph and then annotate it with all the geology. Every time you put a photograph in, you must have a title, some annotations, a scale, and which way you were facing when you took it. Now, the things you're trying to describe are: what is the geology, what's the rock type, the texture, is it fragmental, is it crystalline, is it, what grain size is it, shape, sorting, what structures did you see? Like here we've got bedding planes and joints. Did you see any fossils? Any of these things need to be described and drawn, ideally. The geology, you can then interpret it and say what it means. So for example, if you've got limestone here, as we have, because it reacts with hydrochloric acid, we know it must have formed in a warm, shallow tropical ocean. Because as you probably remember, there's the ocean. So what happens is, because there's the sun, because it's very hot, so the water's evaporated, and any calcite that's dissolved in the water comes out of solution, sinks to the bottom and forms limestone. So you need to explain how limestone forms. Now, we do have a variation of energy levels here. Where the micrite is, it's just calcite, so it's very low energy. It's just this process going on. Whereas in the thinner layers, where there's some particles, then we have some higher energy. Basically, a river is coming in and depositing these round small particles, so we know there's a slightly higher energy. And this is a repeated sequence, suggesting every now and again in a warm shallow sea a river was coming into the lagoon or wherever it was. We also need to explain how these joints occur. Now, these joints occur if you get beds of limestone, they form rocks. Millions of years later they get put under pressure and compressed due to tectonics, and they get bent. Okay, now these are brittle layers. So what happens, because you're bending a brittle layer, it tends to crack at the top surface of the bed, because actually the top of the bed is getting extended slightly, and you get these cracks appearing right across the beds, as in 3 dimensions, because you are bending the rock. It's called a tectonic joint. So tectonic joint, you can look that up, tectonic joint, and you should be able to explain how that forms and what's happened to the rocks at Nappa scar. Site 2, do exactly the same. Get a photograph, put a title of the photograph, draw an annotations on it. You can draw the surface here, the erosion surface is the limestone beds, and this area here is our breccia. We need a detailed description of the lithology, the texture, any structures and fossils. The more you describe, the more measurements you put in, the better your mark will be. So you do a close-up of this and you'd be showing the angularity of the breccia, the poorly sorted nature of the breccia, the fact that it was matrix supported rather than class supported, and every time you draw a diagram you'd put a scale, explain how big it is, the direction facing, etc., and explain how that was formed. Now further is done via the rows diagram. Now you should have collected 25 clasts and their orientation. Now the orientation will be for anywhere from 0 right round to 360. So you can tally them up, add up how many of your measurements were in each of these bands, and that should add up to 25. I've put 50 there, but that should be 25. You can work out a percentage as well, and then here you can transfer the data onto a rows chart. So say you had here 350 to 009, you had 10%. You find that band, which is in this band here, and each one of these is 10%, and so you just shade in one of these to 10%. If it had been 50%, you shade in 50. Once you do one side, you keep going round, and you should have a diagram looking like this. Okay, and then you should be able to work out whether there's a preferred orientation to your clasts. So that's further analysis and interpretation. You can explain how that breccia. Site 3, we have a unconformity. An unconformity here, there's the erosion surface. Above was the basal conglomerate, which was a limestone, and then we had the gently bedding, dipping beds of the slate. We can see the slaty cleavage here. So we need detailed description again: lithology, texture, structure, any fossils present, foliation, dip, strike, all the measurements annotated on with the normal title, scale, orientation. And interpretation of this site, you could go through geological history. So firstly, explain how the shales got there. They form in very low energy, usually deep water, where tiny particles of clay get carried out into the sea and then slowly deposited over millions of years to form layers in deep ocean. Now, if this ocean is between two continental plates that are colliding, eventually they get folded, steeply folded, like this, and you would get lots and lots of the clay particles would be lining up like this, which is a foliation. Okay, this is called axial plane foliation, and it forms a slate. And these are big mountains now, big high mountains formed out of the sea, and then you've got the regional metamorphism due to pressure. Now over time, those mountains get worn down, you get an erosion surface, you get fragments of the rocks underneath in the pile of rubble on the top, and millions of years later, the whole of Britain was covered in a warm, shallow tropical sea, and you get the limestone layers on the top, and these are included fragments of the layer beneath. So that's an interpretation. This happened about 450 million years ago in Britain. This collision happened about 400 million years ago, and then this with the limestone is about 350. So there's the erosion occurred over 50 to 100 million years, destroying all the layers in between. Now, once you've done all the separate sites, you now need to put together a synthesis, put all that information together to come up with either something that backs up your hypothesis or a new hypothesis or a new idea. So here I've drawn a side view of Nappa Scar. This is where the footpath was, and the overhang, and where the proposed fault line is. Site 1 was this lot of limestone. Site 2 was under the overhang, and Site 3 down here. And this is the evidence we were looking for a fault. Have the beds been displaced? Is all the lithology, the textural information, the fossils, the structures, are they exactly the same as this site here? Is this site exactly the same as this site here? If it is, then the beds have been displaced in this fashion and a fault can be assumed. Did you see slickened sides on the fault surface? If not, why not? Was there fault breccia down along the path? We saw breccia here. Was that part of the fault? Did we see mineralisation that could have been formed? If you agree with it, then you can conclude the hypothesis was proved correct. If you don't feel there is a fault, your evidence doesn't point to it, what is the alternative hypothesis or alternative reason for what you've seen? So you then need to draw another diagram like this with your alternative view of what you saw. What was happening here? Was the unconformity under here, and what was this bit here? Was this some localised landslide or coastal erosion? You just make a conclusion, refer back to your original hypothesis, say it was either proved correct because, give the evidence, or it was proved incorrect, and I think this happened because. There we go. So hopefully they found that useful. I'll put something on about evaluation later.